Our next section of notes is on 3.5, which is on velocities. So today we're going to learn how to calculate the angular velocity of objects. So in this section, you will see a bunch of formulas. You can calculate the velocity using the formula, or you can use the method that we're going over today, just because it's a little more consistent throughout the problems, and it'll make it easier for you to do. So basically, linear velocity is going to be distance over time. So the unit for time can change. It could be hours, minutes, seconds, depending on your problem. And distance is like inches, feet, miles, any type of distance measurement that we're used to using. So for example, number 1, a point on a circle travels 5 centimeters in 2 seconds. We're going to find the linear velocity. So we already know linear velocity is distance over time. So our distance is 5 centimeters and our time is 2 seconds. So our linear velocity is going to be 2.5 centimeters per second. This one we didn't have to change any units because it didn't specify what units it needed to be in. The next type of velocity we're going to be doing is angular velocity. And for this one, you can read through the definition, but basically what it means is we are going to be taking our angular in radians per time. So instead of distance, we're going to be using radians for our angle. So angular velocity is going to be radians over time. So our example 2, a point on a circle rotates through 3 pi over 4 radians in 3 seconds. Give the angular velocity of p. So we know the angular velocity is equal to our radians per time. So our radians is 3 pi over 4 all over our time of 3 seconds. And if we were to simplify this, it would be 3 pi over 4 times 1/3. And that will give us pi over 4. And this unit is going to be radians per second. And that is how we can find the angular velocity, is radians per second. Our next example is a bicycle wheel with a radius of 13 inches turns with an angular velocity of 3 radians per second. We're going to find the distance traveled by a point on the bicycle tire in 1 minute. So this problem has a lot of information that we're going to break apart. One thing from, I believe it was section 3.4, we talked about how 1 radian is equal to the length of the radius. So they tell us our radius is 13 inches. So we know that 1 radian over 13 inches is going to be a unit converter. So kind of like how we can multiply by pi over 180 to change to radians. This is the same thing we can do to change our units if needed. They also tell us our angular velocity of 3 radians per second. So we know we have 3 radians over 1 second. And that is another unit converter that we can use in this section. So then next, we're going to find the distance traveled by a point on the bicycle tire in 1 minute. So we need to change this to minutes. With this problem, you're going to always start with your angular velocity if they give that to you, or any type of velocity. So we're going to start with 3 radians per minute, per second. And we're going to start doing unit conversions. So we're going to be multiplying by stuff. We know we need to find the bicycle tire, the distance traveled in 1 minute. So we need to change this to minutes on the bottom. So we're going to multiply by 60 seconds over 1 minute. Okay. And now we also need to get rid of the radians because we don't have, in a distance, we don't use radians. So we're going to multiply by our unit converter for radians and inches. But notice the radians in our problem is on top. So we need that radians to be on the bottom of our unit converter so that the units cancel out with each other. So we're just going to flip that over to put 13 inches over 1 radian. And now we're going to see if we cancel out our units. We've got rid of the radians, and the seconds, and the seconds. Now we're going to have inches over minutes, which is what we wanted to do. And we're just going to multiply straight across. So we're going to take 3 times 60 times 13 on the top. So we're going to get 2,340, and this is inches, over 1 on the bottom, and that is going to be minutes. So in 1 minute, we're going to travel 2,340 inches. So all we're doing is we're using our unit converters to change to the unit that we are looking for. And this is the relationship between the two velocities. So if you want to look at that, you can. These formulas will be given to you on the test, but it is easier to work through the problems by using the unit converters like we were showed in the last few problems. So if you want to use those formulas, you can. It's just a lot of process of trying to figure out where you substitute them into each other. So we're going to go over just using the unit converters in these problems. Example 4. For this one, we have a phonograph record is turning at 45 RPM, which means revolutions per minute. So that's where we're going to start our problem with 45 revolutions over 1 minute. If the distance traveled from the center of the record to a point on the edge of the record is 3 inches, so that's our radius. And if you remember, our radius is equal to 1 radian. So we know that we would have 3 inches over 1 radian. For this, we're looking for the angular velocity and the linear velocity. So to start off, we're going to start with the angular velocity. And remember, angular velocity is radians per time. So this one we're looking for feet per minute. So we know we started in 45 revolutions per minute. So we've already got the time unit in the correct spot. We're already in minutes, so we don't have to worry about changing that. Now we just need to figure out how to get to radians. And the key word here that we're going to be using is revolution. So a revolution is going all the way around the circle. So this up here would be an example of 1 revolution. And if we were talking about the 1 revolution in radians, we know that is equal to 2 pi radians. So that is going to be our unit converter, and this is going to be very useful. You are going to use this one a lot, so make sure you have it written down. So we know 1 revolution is equal to 2 pi radians. So we can use that to get rid of the revolution unit in our problem down here. So we're going to multiply by 2 pi radians over 1 revolution. And by doing that, we get rid of the revolution units, and now we're in radians on top and minutes on the bottom, which is our goal. So we would get 90 pi radians over 1 minute. and that is our angular velocity. Our next one, we're going to do linear velocity. So for linear, we know that we need to have distance over time. We already know the angular velocity, so we can use that if you want, or you can start over at the beginning with 45 revolutions per minute if you would like. So we have 90 pi radians over 1 minute. And we need to change this to distance over time. So this is where our radius is going to come in, because we need to get rid of the radians. So we're going to multiply this by 3 inches over 1 radian. By doing that, we're going to get rid of the radians, and now we're in inches on top and minutes on the bottom. But if you look, we need the feet per minute. So we need to change this to feet. So we know, hopefully, that 1 foot is equal to 12 inches. So we're going to multiply by that unit converter of 1 foot over 12 inches. By doing that, we can eliminate those units. So now we're left with feet per minute, which is what we wanted. And for this one, because it's linear, it's okay to round your answers for this. So we would do 90 pi times 3 on top. And then we're going to divide that by 12 on the bottom. So we're going to get about 70.7, and this would be feet per minute. If it asks for exact answers, then you would just leave pi in your answer and you wouldn't type it into a calculator. All right, so for our next one, example 5, for this one, we're going to find the diameter of a Ferris wheel is 250 feet. So that tells us the radius is half of that, of 125 feet. Oops, sorry, that's supposed to be a T. There we go. And 1 complete revolution takes 20 minutes. So we know 1 revolution is 20 minutes. And don't forget that the radius is over 1 radian, because 1 radius equals 1 radian. We are going to find the linear velocity of a person riding on the Ferris wheel. So we're looking for distance over time. We're giving our answer in miles per hour. So for this one, and this formula or this value will be given to you on the test and quizzes, 5,280 feet is equal to 1 mile. Let me just double check that really quick to make sure I have that number right. Otherwise, we'll get the wrong answer. Yeah, 5,280. There we go. All right. So 5,280 feet equals 1 mile. All of this information we just wrote down is going to help us get our answer. So we're going to start with the very beginning that they told us. We have 1 complete revolution in 20 minutes. So we're going to start with 1 revolution over 20 minutes. And remember, a revolution, 1 revolution, is also equal to 2 pi radians, because that's how far you go around in a circle. So to get rid of the revolution units, we're going to multiply this by 2 pi radians over 1 revolution. Now we know we've got rid of the revolution units. So next, we need to get rid of the radians, because we're trying to give our answer in miles per hour. So we don't have radians there. So we're going to use our radius. So we're going to multiply this by 125 feet over 1 radian. And then those radian units cancel out with each other. So now we're left with feet per minute. And we need to do miles per hour. So we know that the miles is 1. Oh, sorry, that was the wrong part to circle. 1 mile equals 5,280 feet. So we're going to use that to get miles on top. And now we'll see that the feet also cancel out with each other. So now on the top we have the unit we want. We want miles. On the bottom we just need to change that to hours. So 1 hour, we need to get rid of minutes. So we know that 1 hour equals 60 minutes. Oh, but you'll notice if I put 1 hour over 60 minutes, that the minutes are both on the bottom, which is not what we want. We want the minutes to cancel with each other. So I need to erase this and flip it over and put 60 minutes on top over 1 hour. And now we can see that the minutes will simplify because there's one on top and one on the bottom, which is our goal. Once you have that, we can type it into our calculators and get our answer. So I'm going to take 2 pi times 125 times 60 on top. And you don't have to include all the ones. If you want to, you can. And then on the bottom, we're going to have 20 times 5,280. And when you're typing this in your calculator, you can either multiply all the top numbers in your calculator, put that answer, then multiply all your bottom ones on your calculator and put that answer, and simplify your fraction. Or if you want to do it all in one function on your calculator, you have to put parentheses around the top before you divide by the bottom. Otherwise, your calculator is going to use PEMDAS and it'll give you the wrong answer. So for this, our final answer is going to be about 0.45, and that is miles per hour, because all the other units simplified with each other. Okay, the homework assignment is listed below. If you have any questions, just let me know and I'll get back to you as soon as possible.